Ever get so frustrated with like public transit ticketing, you just want to like
Oh, yeah.
scream?
Yeah.
Yeah. Well, some researchers are trying to fix that
Mhm.
using blockchain.
Interesting.
Yeah. And we're going to dive into that today.
Okay.
We're looking at this research paper about a system called STUB, which stands for System for Ticketing Ubiquity with Blockchains.
Catchy.
Right.
Yeah. And it's not just about making payments smoother either. Like, this is about, like you said, a whole new way of thinking about how these transportation networks are even
Yeah.
represented and managed. Think of it like a shared map,
Okay.
constantly updated.
Okay.
Digital map of every bus train ferry,
Wow.
all their stops and how they connect.
Okay, I'm very intrigued. But how does blockchain even work for tickets?
So the researchers, they start with this scenario.
Okay.
We've all been there, right?
Yeah.
You're trying to get across the city.
Right.
Multiple transit lines.
Yeah.
Maybe a red line, yellow line, and a blue line.
Yeah.
And they all have their own separate ticketing system.
Oh, yeah, especially when you're trying to transfer and they just decide not to talk to each other.
Exactly.
The worst.
Frustrating misconnections, fare disputes, the whole thing.
Yep.
And it just highlights how limited these systems are when they're all separate.
Yeah.
It's inefficient, and it can be a security problem.
Okay, so this is where blockchain comes in.
Right.
The technology that everyone's talking about.
Yeah.
But how does it actually fix the problems we just talked about?
Well, this is where STUB comes in.
Okay.
So instead of those like flimsy paper tickets,
Yeah.
imagine every purchase having a secure record of it. On the blockchain,
Okay.
think of blockchain like a digital ledger that you can't tamper with.
Right.
Each transaction is like cryptographically secured
Okay.
and linked to the one before it.
So if someone tries to like cheat the system, it's like leaving a trail.
Exactly.
Like everyone can see.
It's transparent.
Got it.
Removes the potential for fraud, disputes,
Yeah.
because there's this verifiable source of truth.
Yeah. Okay, so no more lost tickets, no more arguments.
Right.
Love that.
Yeah.
But I'm still trying to understand how this goes beyond just replacing the ticket.
So that's where it gets really interesting.
Okay.
The researchers realized just putting tickets on a blockchain,
Yeah.
it wasn't enough to completely revolutionize transit.
Okay.
They needed to create a shared understanding of the entire network itself.
Okay.
And that's where this concept of a transport network ontology comes in.
Okay.
Or TOnNe.
10. Okay.
Mhm.
That sounds a little intimidating. I'm not going to lie.
It sounds very complex,
Yeah.
but it's actually really intuitive.
Okay.
Think of an ontology as like a blueprint, a digital blueprint.
Okay.
In this case, the TOnNe is like a detailed blueprint of the entire transit system.
Wow.
Routes, stops, schedules, how they all connect.
So it's like taking all those like confusing paper maps
Yes.
and putting them
Yes,
into
it's putting them all together.
Okay.
Yeah.
So instead of like every transit provider having its own little separate system, the
Right.
10 is like a shared language
Exactly.
that they can all use.
Yes, and you combine that shared understanding with the security and transparency of the blockchain.
Yeah.
You get something really powerful.
Okay.
You get an Ontochain.
An Ontochain.
Ontochains.
Okay, that sounds like straight out of a sci-fi novel.
It does.
Yeah.
It's very futuristic.
It is.
But the concept is kind of elegant. So the Ontochain basically becomes this incredible distributed knowledge graph
Okay.
that all the transport providers can access and trust.
Wow. So it's like this real-time information sharing.
Yeah, imagine every bus, train, ferry,
Yeah.
all on the same page.
Okay, so we've got our tickets on the blockchain, this digital blueprint.
Right.
But how do we know that the information is accurate? Because things change all the time.
That's where Merkle proofs come in.
Okay, Merkle proofs.
Yeah, think of
Like a digital
like a digital verification system
identification, yeah.
that prevents any funny business.
Okay, so in this context, funny business would be like,
So imagine someone's trying to like
yeah,
change the information on the blockchain
right.
to give themselves a free ride
Oh,
or to disrupt the system.
okay.
Merkle proofs are like digital alarms
Got it.
alerting everyone that something's wrong.
So it's like a security system
Yes, exactly.
for the whole network.
Yeah, and it's very effective because each change on the blockchain generates this like
Whoa, wow.
unique fingerprint.
Okay.
And any discrepancy
Yeah.
raises a red flag.
So everyone has the same correct information.
Yes.
Okay.
So to test this idea, they actually created this fictional transit system
Really?
called the Reading Underground.
The reading underground, okay.
Interesting. So it has 7 different service providers.
Okay.
It's this intricate network of routes and stops.
So they built this whole system just
Yeah.
to test this out.
They had to start somewhere.
Okay.
It was a small-scale model. to mirror the complexities of a real-world system.
That's really cool. So it worked.
So their proof of concept
Yeah.
showed some really promising results.
Okay.
They successfully managed tickets,
Wow.
implemented network updates, and demonstrated that STUB could work,
On the small scale.
at least on a small scale.
Okay, well, that's impressive.
Yeah.
But let's talk practicality.
Okay.
Could this work in the real world?
Right.
Because implementing a whole new system, like
Yeah.
across an entire city,
It seems like it would be.
seems like it would be astronomically expensive.
Right, you would think that, but the researchers actually looked into that.
Yeah.
The economic feasibility of STUB.
Okay, and what did they find?
It's potentially more affordable
Really?
than you might think.
How is that even possible?
One of the things with blockchain is you don't need as many middlemen.
Okay.
Streamlining operations
Right.
reduces administrative costs.
So it could actually save money?
It could save money in the long run.
So it's more efficient, more secure,
Potentially.
and potentially saves money.
Yeah.
That's amazing. Okay, but I imagine, like, actually implementing this comes with its own set of, like,
Oh, yeah, challenges.
challenges for sure.
Yeah.
You can't just, like, flip a switch and expect every bus and train
Right.
to suddenly be on this new system.
Yeah, we can't just hit upgrade and it's all good.
Exactly. And the paper actually acknowledges that one of the biggest hurdles is this, like, integration piece.
Okay.
Because you've got all these different transit providers, government agencies, payment systems.
Oh, yeah.
All with their own technology.
It's like herding cats to get them all to do the same thing.
That's a great way to put it.
Right.
But it's not impossible. The researchers suggest we need some standardized interfaces and protocols.
So like a universal translator.
Exactly.
Got it.
So that even if all these systems are built on different technologies,
Right. They can still talk to each other.
they can all understand each other.
Yeah, and share information.
Okay.
And the good news is
Yeah.
there are already some initiatives doing this.
Okay.
Have you heard of GTFS?
GTFS, that sounds really familiar.
The General Transit Feed Specification.
Yeah.
It's a data standard.
Okay.
And it's already used by like thousands of transit providers
Okay.
worldwide.
So it's probably how all those transit apps work.
Yes, exactly.
Okay.
Like when you want to see.
Right, like when does the next bus come?
Yes.
It doesn't matter where I am, I can just pull up an app and see it.
That's GTFS.
Wow, that's so cool.
Yeah.
Okay, so if we could, like, integrate this STUB system
Yes.
with GTFS.
Yes. So what they're suggesting is that like future versions of this transport network ontology should be compatible with GTFS data.
So it's like building a new system, but it like still has to fit in with the old.
Yes.
That makes sense.
Yeah. Because it's all about the real world constraints when you're designing new technology.
That's a good point.
Especially in a sector like this.
Yeah.
So complex like public transit.
This is like a whole new way of thinking about it.
It is.
Which is really cool.
It's not just theoretical.
Right.
They're thinking about how to actually implement this.
Yeah. Okay. Bring on the blockchain revolution. I'm ready.
Well, hold on.
Okay.
Let's not get ahead of ourselves.
Yep.
This is still very early stage research.
That's fair.
They did this reading underground experiment.
Yeah.
Which is great.
Mm-hmm.
But it's a far cry from a real transit system.
Yeah. Millions of passengers every day.
Exactly. With all these constantly evolving variables.
So how do we bridge that gap?
That's the million-dollar question.
Yeah, right.
Right. So first, we need to scale things up.
Yeah.
We have to test STUB in a real city.
Okay.
With real passengers.
Right.
With real problems.
Yeah, and like different payment methods, accessibility needs, language barriers.
All of it.
It's a lot.
Yeah. So maybe partnering with a city that's open to piloting this technology.
Okay, so like a pilot program to see how it works.
See how it works in the real world.
Okay.
How does the system handle all this?
Right. Because it's great in theory.
Right.
But if it doesn't work for the people every day, then it's not really a good solution.
And that's the most important part, right?
Yeah.
The user experience. Get feedback from the passengers, from the drivers, from the transit workers.
Yeah.
Everyone involved.
It's like we're on the cusp of this major change.
We are.
In how we even think about public transit.
And this is just the beginning.
Really?
Yeah, because this goes beyond ticketing.
Okay.
Blockchain is about tracking and managing data.
Right.
And public transit is all about data.
Okay, so what else could we use this for?
Imagine managing a whole fleet of buses with blockchain. Tracking where all the parts come from.
Okay.
Their maintenance history. Optimizing fuel efficiency.
Like the whole ecosystem.
the whole thing.
Wow. Yeah. It really shows you how many different things you can use blockchain for.
Yeah, it's definitely more than just like a buzzword now.
Yeah,
Like this
exactly.
could really change things.
Yeah. So as we wrap up this deep dive on blockchain and public transit, what's like the one thing you hope people remember from this?
I think the main thing to take away is that blockchain can be used for so much more than we think.
Mm-hmm.
It's not just for like cryptocurrency.
Right.
It can actually
Yeah.
be used to make things better,
Yeah.
like essential services, make them more efficient, more accessible for everyone.
It's really about using technology to make people's lives better.
Exactly.
And I love that.
Yeah. And who knows, maybe
Uh-huh.
soon we'll all be using this and wondering how we ever lived without it.
I think so, yeah. Thanks so much for joining me on this deep dive.
Of course, it was a pleasure being here.
It was really interesting, and it definitely gave me a lot to think about. All
Always happy to do it. Talk soon.
right, until next time.